Okay, homework 8, exponential growth and decay. I'm on a roll here. Okay, write the formula for each function below. So as we learned about in our previous class, if I think about what our exponential growth function is, it is going to be, okay, it's going to be y equals a 1 plus r, and all raised to the t, okay? Remember, you can think about it as art. So remember what the a is? The a is, if it's helpful to write you this, right? The initial amount. Sometimes we also call that the principal, especially when we talk about money. But kind of what we start with. R is the growth rate, right? Okay. And T is the amount of time. So that is our growth function, and that is the form. And this can help you when you're doing your word problems. If I think about my decay, it's going to look very similar. So if I go over here to my exponential decay function, I'm going to have y. This should look very familiar. And then I have my initial amount, or my principal here. I have 1. And I'm going to subtract because it's decaying. It's getting smaller. Minus my rate. And I'm going to take that all to an exponent of t, which is my time. So if it helps, you can rewrite this as initial. Again, you're kind of like your starting point or principal. Your R is going to be your rate. Remember, this time it's going to be the decay rate. And then T, which is your time. Okay, I need a sharper pencil. So I've got some word problems now. So we're going to read this carefully. Annual sales for a fast food restaurant are $650,000 and are increasing. Oh, increasing. I'm going to put that in a box because it's going to tell me that I'm going to have a growth function at a rate, and I'm going to go ahead and circle that number, 4%. Actually, I'm going to circle all the numbers here. At 4% per year. Use an exponential function to find the annual sales. I'm going to underline that, after 7 years. Okay, so really what I'm going to use this formula, if you will, or that form. So I'm going to set this up with y, and then a is going to be my principal amount, okay? So that's kind of what I'm starting with. So $650,000 is what I'm starting with, okay? And then I'm going to put in parentheses, since it's the growth function that I'm using, I always put a 1. And then I am adding the rate. So it's 4%, right? So if I look over here, it's 4%. Well, when you put that in to parentheses in your rate over here, you actually turn that into the decimal form of 4%, which is 0.04. So in essence, this becomes 1 and 4 cents, if you think about it that way. So I'm setting this up. Use exponential to find the annual sales up for 7 years. So now I'm given the time, which is 7, if you think about it right now. Okay, you're going to need to use a calculator for this, but you're going to add, right, 1 plus 0.04, so you're going to get 1.04, right? Use a calculator and use the exponential function and raise 1.04 to the 7th power. Whatever you're going to get an answer, a product, if you think about it that way. And you're going to multiply it all by $650,000. It's hard to show you the calculator since I'm on my phone right now. I just realized, but we'll go for it. Anyway, when you multiply, when you take this 1.04 to the 7th power, and you multiply that by $650,000, you're going to end up with that amount. So check it on your calculator. Okay, that's going to be your final amount. So again, it's increasing, so at least it's going up. That's good. Okay, after 7 years. Let's go for number 2. The population of a town is 2,500 and is decreasing. So I'm going to put that in a box at a rate of 3.5. And I'm going to go ahead because I know it's percent. I already know that I'm going to have to put it in decimal form. Hopefully you were there for class and realized why per year. Use an exponential function to find the population after 5 years. Okay, so I'm decreasing. So I'm going to have to go up to my decay function formula or form if you think about it that way. Okay, so let's do it. So I'm going to start with my y. Y equals, and here's my initial amount or my starting amount. 2,500 people of a population. And now I'm going to use my 1 minus because it's getting smaller. And I'm going to use that decimal form of a 3.5%, which I'm just moving it over. If you think about it, I'm moving over 2, which is 100. And I'm taking that to my time. And so that's the exponent, 5 years. Okay. So you're going to need to calculate again. If I subtract 0.035 from 1, right, and take it to the 5th power, I'm going to multiply whatever I get there, and I'm going to end up with 2,902 people. Okay. So again, I'm subtracting this first. Use a calculator. You can bring it to the 5th power. Multiply that whole thing by 2,500, and you should get this. Okay? I forgot to put this in a box. And this is, if I wanted to add a term to that, I could write sales, right? Okay, because it's all about sales. Okay, we've got a print shop here is purchasing a new printer for $35,000. I think I'm getting the hang of this. This is probably going to be your principal amount. Each year it depreciates. Ooh, it depreciates. It has a DE word, which means it's going to go down. It's a good vocabulary word to know. At a rate of 5%. So I'm already going to put that in decimal form, just so I remember. Use an exponential function to find its approximate value after 8 years. Okay, so here we go. So we're going to set it up. Y equals, let's start, we have a principal amount, $35,000. That is a very expensive printer. Not like the ones we use at Peak to Peak that jam on me every time I try to make your packets. So we are depreciating this, so we're decaying it, if you think about it. And I'm going to bring it to the 8th. Okay, so use a calculator, but if I think about, I'm subtracting 5 cents right from 1, which is going to give me 95 cents. So I'm taking really 95 cents to the 8th power. And I'm going to multiply that whole amount by 35,000. Use a calculator. Now, what I'm going to get is, if I did it correctly, I should have a lower number, just like this, right? It went down. I should have a lower amount than 35,000. When you do this with your calculator, you should get that. Okay, so this is the, it's basically worth, if you think about that word value, it's worth $23,219 about, okay? Down here, population of a school. I'm circling, I see a number. It's going up, okay? So I'm gonna box it because I know it's gonna be exponential growth. I have a rate of 2%. I'm going to turn that into 0.02. Use an exponential function. My population 5 to 9 years. Okay, y equals my initial value, which is 800 students. And I've got in my parentheses 1 plus my 2%, right? And I'm taking that all to 9 years, okay? So if I think about it, this is 98 cents, if you think about it. 0.98 to the 9th power. I'm going to take that, again, use a calculator, and multiply it by 800. You should get a number that's higher than 800 because it's increasing. It's not increasing too sharply. So when you key it in, you should get, after 9 years, you're going to have 956 students. Okay. One more. We'll do one more. Okay. Kathy, that's my mom's name, plans to purchase a car. Oh, I already know it's depreciation because cars, once you drive them off the lot, there's a saying that it already loses a huge amount of its value. So anything with a car is probably going to be decay because it does decay at a rate of, oh, see, that's a high percentage rate. The initial value of the car is $21,000. I wonder what kind of car it was. Use the function to find the value of the car after 3 years. Okay, so it's going to lose a lot of its value, actually, in 3 years, because I know that about cars. Let's set it up. Y equals $21,000. That's what it started off. And then I drove it away and drove it to Montana, and then probably going to be like $15,000, something like that. I'm going to do 1 minus my 12% and taking it to the 3rd power. So if I subtract this, I'm going to have what, 88 to 88.88 to the 3rd power. And I'm going to multiply all of that with my calculator by $21,000. And guess what? I'm going to end up with $14,310.91. Okay. So it's really important to, if you really match your, depreciation increase, right? Some of those words. Make sure you're in the ballpark. And I'm going to end there. Good luck.